Working. Perfect. Yeah. So unfortunately, some of the video won't work because, you know, Murphy's Law, that's just going to happen. So yeah, I'm here to present you today Eos and OMOCL, which is a tool stack to integrate openEHR records into the OMOP Common Data Model. So first of all, who am I? That's a good question. I'm a PhD student at the Free University of Berlin. I work at the Berlin Institute of Health, which is an institute of the Charité University Hospital. I'm a medical informatician. I work at the BIH, as I said, there for several years, and I'm on a part of HiGHmed since 2017. For those of you that don't know HiGHmed, it's a medical informatics initiative in Germany that relies heavily on openEHR. Okay, before we're going to take a deep dive into the CDM and all those details, I just wanted to have a small excursion on the clinical data domain and the research data domain, because often they're depicted as different. I personally, when it comes to data, don't think so. So first of all, what is clinical data? If you take a look in the end, it's characterized obviously to heterogeneity of structure and semantics, and that's why we adapt the clinical information models, right, like openEHR, that we harmonize and standardize this data. Typically, we do that so we can actually capture data standardized. We do that also in project, but that's just not a status quo. So usually what you do, obviously, is build those, I think most of you know, the extract, transform, load processes. So they're quite laborious, not a lot of fun and complex. Yeah, and if you take a research data domain, it's actually quite similar, just worse, because research projects are not limited to a location often, or not even to a region, right? We may adapt the SIM for Catalonia, but when we talk about research projects, we go, for example, within the EU, that you cannot expect people to use the same SIM, right? So everyone has maybe even no SIM adapted. There are people that have different SIMs. Some people use FHIR, other ones openEHR, so you have even more heterogeneous structure and semantics. So yeah, that's really great. So what usually happens is that so out of my experience, yeah, that you come up and agree on a common data model. So you say, okay, let's just take those fields because we need them for our study. Let's bring them into one model everyone agrees with, and then we can work together, okay? The good part about that is if we have a SIM already established, we can define standardized ETLs, yeah? So that's really nice. And that's also what I'm going to talk today about. So most prominent research data standard currently is the OMOP Common Data Model, which is used to harmonize data from different EHRs into one data model. It's maintained by Odyssey, so that's a community as openEHR is one. And what they do, they propose a generic database model and vocabulary to facilitate this clinical research. It provides a multitude of tools on top of that database, so it's not just a model. There's also a tool stack by Odyssey, and it's very popular. As Odyssey states, it has more than 100 healthcare data. They don't have that. There are 100 healthcare databases out there, and from over 20 countries and over 1 billion patient records. Okay, generic database model, OpenStack tooling. Okay, we've all been there. I mean, that's not so special for OMOP. What is special about OMOP and why I love it, in the end, it's super pragmatic, okay? It's the model, it's not some UMLs you look at a website. It's actually a database. So you go on the GitHub from Odyssey and you download that DLLs and you start them. You can start them as a Postgres, for example, and it works. You have your CDM set up, you're good to go. And what is even more nicer, they define the typical fields. I would call it the greatest common denominator you need for research. So you have a fixed set of fields, everything is there, you can start up the database, perfect. And now comes even better. They have with the open source tooling, so same model, same tooling, you can share calculations, you can share the actual outcomes. You don't have to send data from A to B, you just send the statistics output you have. Yeah? So that's privacy-wise perfect. What is even better, because it doesn't stop there, right, is the vocabulary. So what OMOP does in the end is it takes most of the terminologies and nomenclature classifications you have, and they clone them and they stuff it into vocabulary, okay? And what they do inside the vocabulary is map those terminologies on each other, okay? And by that, they harmonize terminologies. Because if you have an ICD code for fever, there will be a mapping to the SNOMED code fever, yeah? And so what they also do, sorry by the way for the, it's the presentation a little bit broken. And what they actually do by that on top is they give these codes, so the SNOMED code fever will have an internal OMOP identifier called concept ID, okay? And if you take a look in the vocabulary, the mappings will be contained as said. And in the vocabulary entry, what they also do, they go to a domain and they decide, okay, for condition occurrences, we want to use SNOMED codes. So declare SNOMED for condition occurrence as standard. And all the mappings they have allow you then to map your ICD-10 codes, for example, into SNOMED, so you don't have to query 20 different codes to get a fever. Yeah? And that's really great in the end. So if you compare openEHR with the CDM, what do we learn? Well, openEHR is in SIM, right? So we have the data to actually populate the CDM. What is good about it, we have fixed fields. Yeah, so everyone has the same model, yeah? Bad side is it's not flexible. You cannot come and introduce new fields or add up, like in HS7B2, where you just add up some random fields in the end, or in Fire, where you introduce extensions, yeah? You cannot do that in the OMOP. But the best is that makes mappings really easy, because the outcome is always the same. The model stays the same. You don't have to deal with a flexible model that changes, yeah? So let's talk about mapping the models, a little bit theory. How do you actually transform from openEHR into the CDM? If we take a look at the models in openEHR, we have a maximum data set approach with the archetypes. We have really rich semantics. I think most of us know the crazy amount of reference model fields that we have that are great to consist a lot of semantics. And OMOP, on the other hand, I would call is a really pragmatic model, yeah? You say, okay, I need these fields for research, that's what we want, but it doesn't try to depict an entire EHR. Okay, so it's less semantically rich at that point. Yeah, yeah. And from now on, if I talk about mappings, I don't care about your templates. That's something you can do locally. I care about the archetype to CDM table mappings. Okay, because in OMOP we're not talking about classes or types. We're always talking about tables and fields, because it's a database in the end. Okay, so if I talk about something like observation, a condition occurrence, I'm talking about the common data model table observation, yeah? Okay, let's get our hand dirty. On the left side, you see the problem diagnose archetype. I think most of us have seen that know openEHR. And on the right side, you see the CDM table condition occurrence. So what would you do when you do mapping? You take a look at the openEHR types, and then you check, okay, what is the correlating part in the CDM? Okay, what does semantically fit that? In this case, obviously, problem diagnosis is not a measurement or so on. It's a condition occurrence, okay? So the next step you would do, you would take a look at the different nodes you have in the archetype and obviously try to map them to the CDM. In this case, we have a problem diagnosed name, which typically contains then a SNOMED code fever as an example, and you would translate that in a vocabulary, and this would end up in the condition concept ID, okay? So this is describing what this table is about. So the patient has the condition fever. Yeah. Then we have a daytime onset and the resolution, which is a start and end date, and the status, which typically also correlates to some vocabulary entry. Okay, I talked a lot about vocabulary entry. How do you actually map a terminology code into vocabulary? So internal OMOP identifier, kind of, for that. So for that, in one you see a composition JSON from openEHR. So that's some serialized. And here we take a look, okay, what terminology do we actually have? In this case, it's SNOMED, and we take the code. Then we go into OMOP in the vocabulary, and surprise, the vocabulary, by the way, it's also some database tables you populate. So in the end, that's just some SQL. And you check, okay, give me SNOMED, do we have this code? Do we have a vocabulary entry? And you can see the vocabulary entry code here under C, okay? At this point, we don't care about the SNOMED code anymore. We don't care about what's here called concept code. What we care about from now on in general is the concept ID, because that's the internal OMOP identifier for that code. Okay? And this is what ends up in the OMOP file, or in the table if you want like that. Perfect. So not everything that glitters is gold. That would be nice, but unfortunately it's not like that. Research heavily often relies, when we want to filter for cohorts or so, on age or things like gender. I think most of us know that this is not strictly harmonized in openEHR. So that's a problem. How do we approach this actually? So what we do is we create an empty person. So that's an empty patient in the CDM. And what we do here is just link the EHR object with its ID to the person. Yeah? If you have demographic archetypes, you can populate this data later on. So that's not a problem. If it's outside, or typical, most of the vendors have an external demographic server, you can populate that as a second step, right? So you first do all the CDM tables, you link it to a person, you know, okay, this EHR is correlated to this person. If you have the demographic somewhere else, okay, cool, I mean, just add it up later on. Okay, let's talk about the tooling. Enough of theory, let's talk about Eos and OMOCL. So the first thing we did was create the OMOP conversion language, which is called OMOCL, which is a domain-specific language similar to the Fire Connect based on YAML. And this allows us to do declarative mappings. Yeah. And what kind of mappings are that? We're mapping archetypes to several CDM or n CDM tables. It can be also one, so it doesn't have to be several, but there is the case that we have one archetype that populates several CDM tables. And what we're actually mapping, as you saw in the theoretical example, is node paths. So you check out, okay, I have a problem diagnosed name, and in openEHR we have we have a path for that. And this is what ends up, right? Because you say, look, the information about the diagnosis at this point in the file, and you need to put it here in the CDM. The second thing, because openEHR is another thing which I'm not so happy about, is the way it handles some terminologies. Often what happens is that terminologies are annotated in the archetype, but in the serialized format you cannot find it. Yeah? So what happens if you go, for example, go check the CKM for blood pressure, you have a dB quantity for diastolic and systolic blood pressure, and there's a SNOMED code annotated. In the composition, it does not end up because it's an annotation and not the dB-coded text. So what we need to do at this point is provide this information to the mapping. And that's why at some point we need to provide concept IDs to the mapping itself. So these are the two things we are mapping, paths and concept IDs. Yeah? There's some other shenanigans you can do with it, which is path iteration. We have some setting mappings optional and some keywords. We mapped already 24 archetypes, which we agreed are the most important ones for the research. So that's some stuff you need typically for summaries, and that's where most of the research goes into. So these ones are already done, and obviously it's open source. It was part of a research project, so actually it's a paper. And you can check that out on my GitHub. I don't think anyone has such a stupid name, so I think it will be easy to find. Okay. So here's the file. I'm actually going through the file with you just to show a little bit how it works. In the first row, you have the openEHR archetype, so that's the mapping we're defining. Then you define the CDM table you want to map to, which is a condition occurrence. And here we have the condition occurrence concept ID I showed you in the example. So that's where the fever would end up in the archetype. And you say, okay, I want to have in this concept ID this path. The concept ID here is a keyword. It actually fills out several fields, but let's not bother with that. The important fact is the fever ends up in the condition occurrence concept ID. Then we have a start date, which here has two paths. What's actually happening here, it's very simple. If it doesn't find the first one, it takes the second one. Okay, so it's just an OR. Yeah. So and here we have a path iteration. So if the onset is not filled out in the template, because we can change things in the template, please take a look at the context. Then we have a condition end date, which is set optional. That actually means if this field is empty in the template or in the composition in the end, don't bother. It's not mandatory. Okay, we don't need an end date. That's something in the end the projects have to decide. If a project says, okay, I want to have an end date, otherwise this is useless for me, you just throw out the tag. Yeah. And finally, we got in the last row, you see the code. That's for an example now, confirmed diagnose as a status that we want to set, okay, in case the cluster is not out. That's just for explanatory reason. It's not 100% correct in this case, but just to show you, okay, we can set here concept IDs from the vocabulary directly. Okay, so far so good. I hope that wasn't too much confusing. What are files without an engine to actually process them? I mean, we can build air castles for the next 10 years, but it's good to see if it's actually working. So another thing we did was an ATL engine called Eos. This ETL engine loads and executes the OMOCL files we defined. It's a Spring Server with heavy usage of openEHR SDK, so it's quite conservative. Mappings are triggered via API calls, so you just do your REST calls. It's open source. Check it out. Yeah, how does EOS actually work? So the first thing EOS does is extract or load the OMOCL files from a directory you specify. And as a second step, you can extract from openEHR. So usually the first thing you do is generate the link between the EHR and the person, right? Because you need a person to populate data to. That's just some click. And then you can load either all compositions from all EHRs, you can load just a specific set, because in research, typically you define cohorts. So what you do is, okay, I want to do diabetes research. So what you would do is write an AQL, give me all EHRs, EHR IDs of patients that have the diagnosed diabetes. And with that IDs, you can just tell the EOS, okay, just give me these patients, because that's the ones I need. And what EOS then does, takes the OMOCL files and via them is enabled to transfer into the CDM. There's also a conditional grade, so you can send a single composition to EOS and it will create the correlating CDM table. Okay, so as I said, we don't want to build air castles. Odyssey actually provides a data quality dashboard. This dashboard actually verifies and validates your CDM database. In this case, we passed with 98%, which I think is great. That showed, okay, the stuff we actually did, it's working and the quality is good. Yeah. Yeah. The video is not working, but actually there's not so much happening, yeah? So what I'm in the demo was, in the end, I'm sending a composition. The URL actually contains the EHR ID, so it's similar to the standard openEHR API. And what's then happening is just that the composition is translated to some table and there's a JSON output. Yeah, so what will happen when you send a single composition, the CDM table will be mapped, it will be populated, and there will be some log output. Yeah, yes, you see, it's not working. So, yeah, we have a picture at least, yeah. So you see up in the URL, there's the EHR ID contained, yeah. That allows us actually, or the tool actually, to find the person, yeah, because it knows to this EHR ID, I created a person, yeah. And then you have, in the body, you have the composition, which is typical, and what would be the response is just some information about the table, yeah. Perfect, so what's my conclusion about the CDM? It was not an Odyssey, even though the slides may illustrate that. It shows, along with a lot of other papers, that openEHR is predestined for a transformation into less semantic rich models. Yeah. So this is important because in the end, if you want to build up an EHR, you want to know how to transform this into less semantic rich models, right? Like OMOP or even FHIR and so on. Okay, and also we enabled openEHR projects in the end to support the CDM for the 24 archetypes that are out there, and you can write your own mappings if you want to. Yeah, if you want to check out the paper and know more, click on the link. Finally, what's the last two slides? What do we plan for the future? We want to extend and maintain the tooling and the mappings. We want to add the openEHR vocabulary, because you can, to the vocabulary, you can add stuff, you can propose to the Odyssey community. And what is more important, what we wish to do, we want mappings to be part of the quality process and the workflow that models go through. Okay, so what we want is actually attach the OMOCL files in the CKM to the model, and hopefully also the FHIR mapping files. So the harmonization between standards is part of the modeling itself. And no other standard has that. So you open up the openEHR type and you have directly two mappings to FHIR and the CDM. And I think that would be really great. Okay, just one last slide, a little bit PR for another initiative I founded, which is the European openEHR network. From OMOP, I learned that the international archetypes we have are really worth in gold. Yeah, because without them, I couldn't define comprehensive mappings, right? Local archetypes mappings are a lot of work. And we want to strengthen the cooperation between openEHR institutions, also for modeling, and we want to define a basic framework how to collaborate. What are the technical infrastructure needs? How do we deal with governance? How do we deal with privacy? So if you like this project and you have openEHR data, come to talk to me, to Eric Sandwall, to Jordi from Katzelut, to Stefan Becker, and to Vanessa from Luxembourg. And yeah, come to us, ask us. We're still open to get more institutions in. Thank you from my side. I hope you enjoyed it. Yeah, are there any questions?
Thank you. That was fast.
Yeah, I mean.
Okay, questions? Okay, one. Okay, let's start with this one.
That was really interesting. Forgive me if I've misunderstood, but I was really interested when you mentioned that you kept your empty patient model in the external databases and then referred to it with an ID.
Yeah.
This is a problem we've come across in our shift to openEHR, and we were leaning towards the decision of keeping the patient data, the demographics, in our main application database because of the relation. Because of the helpful relations it have to other entities in the application, like the clinician, the care center, etc. Are there benefits to doing it the way you've suggested by just keeping that patient relation empty and always referring to the openEHR and to the openEHR composition? And does that lead to any issues, latency, etc.?
So maybe I didn't get the question 100%. So what you ask is in the end, if it would be good to leave inside the CDM the person empty? Did I get that right?
Yeah, exactly.
Yeah, that's you don't want to do that because without gender and age, 90% of the cohorts are gone. Because in research, really often people want to know the gender and the age, and you need that information. I mean, as I said, it doesn't have to come from an openEHR demographic archetypes. You have these cases where we have, for example, set up a research data repository with openEHR. At this point, you need the demographics. Also, it can come from an external server, right, as most of the people do. But in the CDM, I mean, depending on the project, but usually you need this data. So leaving the person itself empty without the gender, without an age, and so on, depending on the project, I mean, you can do this, but why not, you know?
Okay, another question? Yes, one in the back. Oh, I have to run.
Regarding the mapping from openEHR to OMOP, is it possible to do it the opposite around? What's your stance?
Good question. Why would you do that?
Yes, first question.
I mean, why would, yeah.
One reason I can imagine is to have an openEHR project getting started when a OMOP database is already in place, to have like a, let's say, POC of openEHR set up quickly. That's like, yeah.
I get the point. I think, yeah, I mean, in general, the cases, in the practical cases that most of, so I thought about, for example, transforming the biobank data set, which is, you can in OMOP into openEHR. But I think to set up a project, you need sample data is good enough for trial, right? And most of the times there's just not the need to do this direction. Surely I could add it, but in the end, it's not a business case. I'm a researcher, so you know, time is short. And the use case is just so sparse, so that's why we didn't do it. Yeah. All right.
Okay, some other questions? Okay, I do have a question, perhaps a stupid one, because
it's okay.
I don't have experience with OMOP. I'm guessing you do a lot of searching in the OMOP database, data source.
Yeah, obviously.
Is there a way to convert or to map the query, or to have something like a query on the fly that you do an OMOP query and that converts to an AQL?
I mean, you could do that, right?
or maybe you saw an initiative going in that direction?
I don't like these query language mappings. You know, we did it in HiGHmed. I'm not very convinced. In the end, what you can do, you know, just write the SQL. So why go through the process of AQL? Surely you could then support 2 databases. But I personally think, again, I mean, you could do that probably, but I think the possibility that you need that is so small.
Okay.
Because usually you populate data into the CDM from an EHR, right? So why would you want to search an EHR and a research database?
I was thinking something
yeah.
a real-time query. I don't know. You
Real-time queries.
especially with, you know, I don't know if it's again, it's a random question almost.
No, it's okay.
If you have the federative layer, so just imagine you have platforms kind of federated in a single place of
Yeah.
to make a query.
I see it more like a mirror. The CDM, I think, should be a mirror. It shouldn't be only a dump for a specific project. I think it makes sense to have something like a research data repository that's kind of partly a clone from we cannot clone mirror. Yeah, and you keep that, you know, because you can conditionally create and upgrade stuff, and then you just do the SQL there because it's a mirror.
Yeah.
So that's what I think is more practical, because there are a lot of evolving projects for the CDM. So keeping a CDM up and running makes totally sense.
Okay, thanks.
Yeah.
Thank you.